ER diagram tool, so you use the Irwin software. But if you want to use the different software, like some student likes to use the Visio, some student likes to use the UML drawing tool, it doesn't matter. So Irwin software is one of the example of this database design management tool. Actually, the Irwin software is not only for the ER diagram, it can be used for the database creation, database management also. Whether or not you realize, actually you can connect the database using your Oracle account and password, and if you give the proper information, you can actually connect to the Oracle database, any database. Then if you actually create the entity, automatically create the table on the server. So it can be used for the database management tool. Some project manager would like to use such a tool. So also, there are the rational rules from IBM. Such a tool can be used for even software management tool. So which means if you create the entity and something, the method function in terms of the object-oriented model, it automatically creates some component. So the only thing you need to do is such add the algorithm or logic inside the component or the classes. So after you graduate, if you get a job, probably you will be introduced by the project manager to use this kind of software management tool or the database management tool or design management tool. And at the time, so you should be able to use such a that. Okay, so however, we couldn't complete the one more thing, extended ER diagram last time. So today we are going to complete quickly and continue the relational database model. So for example, when you are doing the database design, your customer asks you to create the database by handling some files, bunch of files for the secretary. So we have the 1,000 secretary worldwide, and also we have the engineer. Okay, and also we have this much the technician. So you got the 3 parts of the information. So one is for the secretary, and another one is engineer, the third one is the technician. So it is obvious. For example, secretary has something information about the name, ID, address, and the typing speed. And engineer has also name, ID, address, and the engineer type. And technician has a name, ID, address, and technician grade level. Okay, so you can find such information. So it's very easy to find the entity for secretary. Okay, then we can use ER diagram notation, secretary, name, ID, address, typing speed. Also we have engineer, name, ID, address, and engineer type. And we have technician, name, ID, address. This is the technician grade. Okay. Then we decide this is a key attribute, Okay. So we can find the 3 entities from the requirement. Then can you realize that name, ID, address, name, ID, address, name, ID, address are the common, right? Common attribute, which means, as you can see, secretary is what? Employee. And engineer is also employed. And technician is also employed. Why don't we combine together? Right? For what? Like employee. So for example, instead of the 3 different entities, what about the employee? Okay, then we have the name, ID, and address, common information. Okay, that makes sense. So you can suggest that you can add this attribute. However, the engineer technician does not have information about the typing speed. Similarly, engineer does not have the typing speed and the engineer technician grade. Okay, so using the ER diagram, ER notation, ER modeling, we cannot fully represent such an information. Otherwise, it will be separated to address that problem, which means employee is a secretary, employee is an engineer, technician is employee, engineer is a engineer, the employee, secretary is a unemployed. Okay, there's something is on relationship. So to address that problem, we are going to adapt the idea of superclass and subclasses that you have learned in object-oriented the design model, which means, so why don't we make, so this one, name, ID, address. It's a command. Name, ID, address. Name, ID, address. Then, why don't we create common employee superclass? Then it will keep the common information. Name, ID, address. Then key attribute. Then we cannot use the relationship that we learned in the ER model. Relationship means the relationship between two entities. However, secretary is unemployed, right? It's a different relationship. To represent that one, we are going to define super and subclasses relationship. Okay, actually it's not a relationship. It's a super class and subclass. Actually, employee include all these information. On the other hand, secretary is unemployed. This is called superclass and subclasses. Okay. The reason why we define super and subclasses is the ER modeling itself is very easy to understand. It's a very straightforward to apply to design the general information. However, it's not very flexible. Because of this, it's not very flexible. Unlike the object-oriented design, it's a different modeling. It's a different types of the design. Okay, so you cannot represent such a property. So we are going to enhance or extend the idea of ER. That is called extended, or sometimes it's called enhanced ER modeling. Usually we call it ER modeling. At that time, this is called superclass, and this is a subclasses. I'm going to ask a question. How many entities in the ER model? One. It's just one. Okay? That's the reason we cannot say this is the relationship in ER modeling. Relationship in ER modeling is a different entity. However, we define this one based on this. This process is called bottom to up or generalization. This is called generalization. Also, there is another example. Your customer gave you just one file for the employee information. Okay, then you are going to design model that is employee information. Then you realize that name, ID, and address as the common entity. Okay, attribute. Then when you see the sum of the group of the employee, they have only the typing speed. Okay, in the employee file, only this employee have the typing speed. Then the other group of the employee has only engineer time, and the remainder has the technician grade. At that time, you can realize that there are 3 different groups. Also, when you analyze the application, okay, most of the application can be classified into one of 3 groups. One is only for the secretary, another engineer, another technician. So why don't we separate? Even though your customer gave you the only one entity information, employee, but by analyzing your data as well as the application, you can find from the employee entity, you can find these 3 sub-entities, sub-classes. This time, this is also super and subclasses. This is called ER modeling extended or the enhanced. It doesn't matter. So some of the textbook use enhanced, some of the textbook the extended. It doesn't matter. So ER diagram. At that time, this process is called top to bottom or specialization. Actually, generalization and specialization are very, very common processes in human thinking. Okay, why don't you think about go back to the 2 years old, 3 years old, when you learn the language from your mother. So, for example, your mom, in my case, my mother, she gave me the example of this is the apple. Okay. So red thing and round thing and a little bit the spice, not spicy, anyway, juicy, this is apple. Then next day she explained this is also apple, but it's not the exactly same thing, but it's also apple. Sometimes blue, the green apple. Okay, this is another type of word. But then eventually the process kind of generalization, rounding and the red or green color shape of the fruit is the apple. Then next time when I see the new apple, brand new apple, I never seen this apple, but I recognize this is the apple, right? So it's a generalization and specialization. It's a iterative work. That is the actually thinking process. It's the same thing. Even though I'm teaching only the couple of the 3 or 4 examples of the ER modeling, okay? Then, however, after you graduate, you can actually design any kind of the ER modeling. So from the sum of the example, you generalize the process of the ER modeling, then you can apply, specialize to the specific cases. It's a generalization, specialization. It's a very, very common process in human life. It's the same thing in modeling. So you can use such a super and subclasses to specify the characteristic of the entity. Okay, this is a very common in UML modeling or object-oriented modeling. Okay, you can define the class. You can inherit. There is one of the very popular characteristic of the class, the object-oriented modeling, it's the inheritance. Okay, then you can specialize this one. It's the same thing. Unfortunately, later when we learn the relational database model, this is the ER model. It's a conceptual model. It's a high-level model. But if we apply this one to the database modeling, that is the relational model, there's no way to reflect the characteristic of the super and subclasses. It's obvious in object-oriented modeling, but not obvious in relational model. We need to take care of it. Okay, maybe next class. But it is true. In our real life, we can find many example of this one. It's the same thing in your the assignment, third assignment. So part of your ER diagram should use this part, but I actually do not ask you to do this. Some of the students actually the preview and study the ER diagram and answer correctly, but it's okay. So why don't you, when you get your the assignment sheet, so why don't you try to revise this one by yourself? Okay, so this is the enhanced or the extended ER modeling. Then to specify the generalization or specialization, if this entity, the super and subclasses, is defined by the generalization, which means top, bottom to up, you can use this symbol. Top, bottom to top. Okay? It's a top, the symbol. Or if you identify this ER modeling using the specialization, top to bottom, you can use this symbol. Okay? To specify how you can identify the super and subclasses. But it's not critical in real project. In real life project, there's no difference between generalization and specialization. So, however, you can specify how you can define this super and subclass using either generalization or specialization. Yes? Okay.
They're talking about the same thing, that it can be, the same diagram can be...
Yeah, it's actually for the database modeling, it doesn't matter whether you detect, you define this, the super and subclasses, either generalization or specialization, it's not critical, okay? So, however, to specify, you can use this or this symbol. Okay. Another thing is, there is a circle to represent the characteristic of the super and subclasses. There are two main characteristics of the super and subclasses. One is the participation. Okay, participation means whether employee all superclass entity in the superclass participated in subclass. For example, there are employees who are not in the secretary, who are not in engineer, who are not technician, which means this employee is only in the just employee, not technician, not secretary, not the engineer. Okay, which means this super and subclasses is optional. Okay, at that time you can use single line. Okay. On the other hand, all employees should be either secretary, engineer, or technician. Okay. At that time, that is called full participation, mandatory participation. At that time, to represent the full participation, always we can use double line. Okay. So when you see the double line, that means all employees should be either secretary, engineer, or technician. Also, there is another thing you need to consider. Sometimes some of the employees are both engineer and technician. That may be possible. So when you take a look at your customer file, when I see the technician, I can find the lead. And another file is also lead, which means that this employee is both engineer and technician. Another example is what about the GA? GA is a student as well as the employee, part-time employee. So it's a both of entity. So at that time, that is called full or partial, and also that is called overlap and disjoint. So overlap means you allow multiple participation or in the subclasses. On the other hand, disjoint means one of this. To represent this one, O means overlap. You allow the multiple participation of the subclasses. This joint, this circle means it's a one of this. Okay, so there are four types. One is full disjoint. Second, full participation plus overlap. 3, the optional or partial plus disjoint. And partial plus overlap. So one of these, any of the super and subclasses is one of this. You need to identify such a thing. Okay? So, for example, in this case, what does it mean? Double line and D is a all employee should be either secretary or engineer or technician. Okay? If I change the D into O, means all employee should be at least one of this subcategory of the employee. What about this? Employee may be none of this or any of this. Okay? So you can understand easily. Double line, O means, so employee should be, we already did. So it's one of this. So this is the super and subclasses. So idea is we employ the idea of the object-oriented program to define the real life example. Okay, any question? Let's take a look at the example more. So this is the example of the super and subclasses. So we can see the employee. Okay, this time, question: is it generalized or specialized? Generalized. It's a generalized, which means the first you identify that this entity, this entity, this entity. Then we realize that these are the employee. Okay. Then what types of the super and subclasses? This. It's a partial participation and disjoint, which means there might be employee who are not in none of this. There are, if the employee is one of this, then it should be secretary, technician, or engineer, or none of this. Okay, that is a partial disjoint. Okay, then how many super and subclasses? This is one superclass and subclasses. Okay, can you find how many super and subclasses relationship in this? Before that, how many entities can you find? Employee, right? Project and trade union. There are 3 entities. Then how many super and subclasses group? How many groups?
1 superclass, 5 subclasses.
5? 1?
6 subclasses.
6?
3.
My question is, so this is one group of super class and their subclasses. So how many groups in this region? 3.
3 groups.
Let's see. So employee inherit their information to this, right? They are connected to this disjoint. There's another one, employee and manager. But this time, how many subclass? It's only one subclass. That may be possible. Inherit, employee to the manager. There's another one, employee, salary, employee, hourly employee. So there are three, super and subclasses group. Okay? But what types of the manager? It doesn't matter. Either overlap, disjoint, because we have only one subclass. That is the reason we do not specify the circle O or the D. But this is the generalization process, which means you realize there are managers, okay? But manager is also employee. So that is the reason we create the super and subclass. What about this one? What types of the super and subclasses? So full participation, which means employee should be either salary employee, hourly employee. Okay? And also disjoint, either. Okay? So there are three. Also, you can create another important thing is you can create a relationship. Not always with the superclass, but subclass. So that is the reason we can find the manager relationship. This is a relationship that we have learned the last time between project and manager. Similarly, the trade union, hourly employee belongs to the trade union. Okay, relationship. Okay, so this is the super and subclasses example. Oh, one more important thing. What is the key attribute of the employee? So SSN. So obviously you can find on the bar that represent the key attribute. What about the secretary? It's also SSN. Why? Because this subclass is a employee. So is a relate. In other words, all characteristics of the employee inherit to each subclasses. Okay? Each subclass. So this one, even though it's not represented, secretary has the name, social security number, birth date, and address. Technician has all this information. Hourly employee, all this information. So even though there is no the key attribute here, it's automatically SSN is a key attribute of the subclasses. That is the super and subclass group. Okay. So sometimes to clarify how we can find these subclasses, we can specify job type over here. Some of the designer likes to enter job type only as an attribute, okay? But some of them put the attribute that can classify the subclasses. Then sample the value of the job type for the subclasses. Okay. Yes.
The job type differs in every subclass. Why we are giving it in generalization?
So this is actually from generalization to find. So in this case, it's a generalization process. So secretary, we found the secretary, technician, and engineer type. Okay, then we generalize to the employee how we can from the employee how we can recognize who is the secretary, who is the technician, who is the engineer, using job type attribute. So intentionally, we add job type attribute to the employee superclass. Okay. Then to clarify, in addition to the attribute, you can put the job type, the attribute that is used for classification. You can use you can put such an attribute next to the line. Okay. Then these are the examples.
When we add the classification as a attribute.
Which one? Yeah, it's an attribute.
No, is there any other name? How can we know that this is a type where we are specifying the
Oh no, we do not specify such a thing. Okay, so that is the reason we put next to the here to clarify such a cases. Okay.
Professor?
Yes.
Yeah. Can you go to the previous slide? No.
This one.
So here employee have to be salaried or hourly because it's a mandatory.
Mm-hmm.
Okay. But employee will be if employee is a technician or engineer,
Oh, sure. Mhm.
and he or she has to be salaried and hourly also.
Sure. Mhm.
So how can there are like two entities?
Oh, no. For example, this is the example of me. So, Lee, 111 social security number, and the January 1st, and the address here. Okay? Then, I'm technician. Okay? And I'm not manager, but I'm hourly employee. Then at the time, your information is here, and my information is here, general information, and technician information, and hourly employee information here. But no manager information, for example. That may be possible. Also, it can be possible, I'm also the manager, technician, as well as the salaried employee. But this is not possible. So I'm technician and manager, but not here, because this is a full participation.
So there should be any classification, must be a classification between these two, salary employee or hourly employee.
Yes, it's either of them, it's a classified. You need to, in this case, you find the all salaried information and hourly the employee the information, so you generalize to the employee.
Yeah,
Okay.
and if I'm a technician and manager at the same time,
Mhm.
then why don't we have that override generalization here?
So which means, so his question is, why don't we combine this information and this,
Yeah,
right?
if
So
you-
that may be possible, but the subclass information are totally different. This is the case 1, case 2, case 3, but this is not the case 4. But it may be possible if we really want to combine secretary plus manager, secretary only, and technician manager, technician only. But it's too complicated, right? So that is the reason we classify it this way. Just like when you have the person class, you can inherit. You can create another student class and instructor class and the employee class. Okay. However, I'm instructor as well as employee. Do I need to create another instructor plus employee class? No. I can be part of this one. So that is the same idea. Okay. So we already discussed most of the thing. Okay. There's another example of the generalization in ER model. So let's say we design the vehicle database, car and truck. Okay. First, we define the car, whose key attribute is what? How many key attributes? This time, so vehicle ID. One is the vehicle ID, another one is the license plate number. Okay, we have the two key attributes. That may be possible. Okay? As we learn in the ER modeling, we can have no key attribute entity. And 1, 2, it doesn't matter. What about the truck? Truck has the license plate number, vehicle ID as a key, 2 keys, and tonnage, number of axle, price. Then we realize that there are common attributes, this one, and this one. The license plate number, vehicle ID, and price. These are the common information. Also, semantically, the car and truck, both of them are vehicle, right? So we define the vehicle as the superclass. Then put the vehicle ID, price, and license plate number. Then also we can select the vehicle ID and license plate number as a key. Then this max speed and number of passengers are the attributes only for car, and number of axle and tonnage is for the truck. It's a full participation, right? Also disjoint, which means any vehicle should be either car and truck, but not both of them. But nowadays there is a passenger car that can be converted to the truck. But anyway, we follow the requirement. Okay, so we can use such as super and subclasses to represent the very diverse information about the requirement of your database. However, unfortunately, relational database model, not the conceptual model, database model, cannot reflect such a characteristic. That's one of the problem of the relational. We will see later. So we learned there are two constraints, two types, the disjoint or overlap. And completeness is a full participation, partial participation, mandatory or the optional. So there are four: disjoint, total. Total means full, disjoint or partial, and overlapping total, overlapping partial. Okay? So it's one of this. What does that mean? That is the ER diagram. We have a part and manufactured part and purchased part. So all part should be either this one or both of them. Right? It can be manufactured as well as a purchased part. Okay. What is the key of the purchased part? It's the same thing, part number. All the attribute in superclass will be inherited to subclasses. Okay. So that is called the inheritance. Okay, so far we have the single inheritance. Okay, but we can generalize such a super and subclass to the hierarchy. What is a hierarchy? Why don't you go back to your data structure class? So in the data structure class, probably at the end of the data structure class, you learned about tree as well as graph. What is a tree structure? Process your brain. It has a node data. Always you define the node in your data structure class, right? So it's a linked list has the node, and even the stack has a node and something. In the Java, you have that node has a reference address of the information, something like that. So tree has a node. Okay, then each node has a special relationship. What kind of relationship? Parent and children relationship. So there are top of your tree structure. It's a root node, and on the other hand, leaf node. So root node does not have parents. Top of your tree. On the other hand, leaf does not have any children node. What about graph? Graph is quite similar, but it doesn't have any parents. So there are there is just group of node and also set of edges, vertex. What is the edge? It's between two nodes. Okay, so it's more generalized structure of the tree structure. So we can generalize. So our super and subclass to the hierarchy. Okay. So if we have only one superclass, okay, like I have only one parent. That's a user in human being. What if we have two parents? Suppose that two parents. By the way, it's just we have mother and father. So our DNA actually inherited from the mother and father. That makes sense, right? That is called the tree structure. That makes sense. Okay? But it has a mutation, so slightly different from our parent, not exactly the same. But in our ER modeling, so if we allow multiple inheritance, which means multiple the superclass, that is called more generalized structure. It's a tree structure. Okay, so let's take a look at the example of this one. First, how many entities? It's one. It's an employee, right? How many super and subclasses group can you find? 1, 2, 3, and 4. Okay? Why don't you take a look at engineer and underbar manager. This one has how many superclass? 1, 2, 3, super multiple inheritance. Okay? Which means this one engineer manager has all information about employee definitely, and also all engineer information, engineer grade, and all manager information, managing department, and salaried employee information will be inherited to this one. This is called tree structure. Okay? So ER diagram allow tree structure also. Okay? What about this one? How many entities?
One.
It's an extreme case. So only one person entity. Maybe your customer gave you only one person information, bunch of 5. Then your job is to identify subclasses. Based on what? Your data itself, also application. If your program access the staff information, faculty information, employee separately, then you need to specialize. In this case, mostly generalized, which means that your customer gave you all different information that generalized into person. So you can see that this is one of the group person, either employee, alumnus, student, or any of them. It may be partial employee plus alumnus, and or student also. Then student assistant is inherited from employee. Also student. So that is the reason it's called the student assistant. So it's a tree structure. There's the last one, category. Category means, so far, even though we have the superclass, multiple superclass, this superclass is how many entity? 1. Okay? This is also 1. And what else? This is a 1. This is a 1. This is a 1. Right? Either tree structure or the single inheritance structure, only one entity, one superclass in the super and subclasses. What if we have one super and subclasses relationship, but multiple different types of the superclasses? For example, when you purchase a new car, or even used car, how can you pay? If you have a cash, so you can pay off. You can buy the car right away. Mostly, you got the finance, right? So there are different ways of the financing. One is you can get the bank loan, right? Also, you can get the manufacturer financing. For example, Toyota provide their own the financing, okay? So there are 2 different ways to purchase a car. Also, when you purchase such a financed car, who is the owner? You and your bank, right? You cannot get the title when you purchase a car with the finance. Really, once you pay off, then the bank send the title of your car. Really, I never see my car title yet because the bank owns that car. So once you pay off, then they send it. So which means how many different owners? It can be bank, me, and also if you have another, the finance manufacturer, 3 different owners, 3 different parents, 3 different the superclass. That is called the union type. For example, here. It's the owner, but owner is a subclass. It's not superclass, owner. But this owner is inherited by person, me, or bank, or company. It's union, all of subclasses. Okay? This is still sub and the super and subclasses. And superclass, it's a superclass. Superclass has different type. This is called union type. Usually, this is a category of owner. Okay? So extreme case. That may be possible. So these are the owner, but it's a different types of owner. At the time we can use union, all of this. The problem is person, what is a key attribute? SSN. What is a key attribute? The bank name. What is a key attribute? It's a company name. So we inherit all of this to the subclass. Then how many key? Social security number, B name, and C name. Which one will be the key of owner? We cannot use only the social security number, right? We cannot use only the bank name. We cannot use only company name. Instead, we need to combine all together. Social security number plus the B name plus the C name. Too complicated. So we need to create artificial key. So that is, for example, owner ID as the key. Then we assign owner ID as the attribute of this one. Because person should know, and bank should know, and the company should know to whom I loan the money. Okay? So this is will be attribute owner ID. This, the key is called artificial key, or sometimes it's called surrogate key, which is a very popular where the database design. What can be the example? You are going to create the customer database. So customer name, there's a name, and also the address and gender and all information. So you need to decide the key attribute. But there's no social security number information because it's a privacy issue. So how can you? Do you need to combine all the attributes? Instead, you can intentionally create customer ID. That is the reason in real life database design, you can see a lot of something ID, something ID, something ID. They are not in your customer requirement, mostly. But you can intentionally create such an artificial key, like this one. This is one of the examples. Sometimes, if key attribute is too long, okay, then you can replace. Why we need to replace such a complicated composite key by this artificial key? Just to look better?
So that
Performance issues. Why?
so that we can specify the things as
Sure.
we want.
Suppose that social security number is a 9 digit, it's a 9 byte, and the bank name is a 10 byte, company name is a 10 byte, total 29 byte for the key. In the memory, you probably learn in your data structure course, so analyze the algorithm by space, so memory space. You need the 29 bytes per node. What if you have millions of owners? It's huge. Instead, why don't we create 5-digit customer number or 10-digit customer number? That can reduce the memory space as well as faster. Okay? Instead of such a character number, why don't we use the number? That will be faster because in the instruction on your CPU processor, CPU provides very fast such a numeric operation. This one is much faster than to compare the 30 by the character string comparison, right? So because of that, we use a lot such an artificial key or surrogate key. This is the same. We can use the owner as the owner ID as the surrogate artificial key of this one. Okay.
Professor, one question.
Yes.
So if I were to create the owner ID attribute, where would I place it?
So we will see. Oops, it's not here. Then we can owner ID, okay? This is the key of this one. Then we can display the key of this. Okay? Then we will clarify more details. So when we create the database model later, okay? So this is called survey. Why don't you keep in mind? This is also the same example. Actually, I think that this is intentionally created such a union type case. This is subclass. So registered vehicle are inherited by car and truck, but this is a union. This is not overlap. Previous example is the car is entity, truck is entity. Then we can generalize to the vehicle. But this is a subclass. This is a superclasses. This one is a superclass, and it's a union type. Either it's a category. Okay, either vehicle is either car and truck. This time, we can use the vehicle ID still because it's a common key attribute. We don't have to create a new surrogate key.
So why the superclasses are at the bottom? How come?
You can upside it down.
Then
Yes, yeah, it's the same thing. So that is actually many of the students confused why this is not always the employee can be here. You can secretary, technician. That may be possible. Okay.
And then we can know that the superclass is at the bottom and the subclass is in the up. Here,
Yeah,
the
sorry.
subclass is in the middle.
Yeah, that's true. But this is just the example. That's the reason many students are confused. But this time, why don't we make it this way? Then, much easier to understand. Okay? So that is the reason I do not actually emphasize on this part a lot. So it's confused. Only because of this one, so it can be different.
So
Okay.
how can we identify here that this is the superclass?
Most of the case, you don't have to identify from the ER diagram. Instead, you need to make the ER diagram from the requirement. That is the reason I do not emphasize on this part. So, but you should be, as long as you can understand, this is a union type. It's a superclass, but superclass is categorized. So, and then it's okay.
Professor,
Yes.
how many inherited in this case?
In this case, how many entities? The owner and registered vehicle. Actually, person, bank, company is also entity. And this one is the entity. Okay? So this is entity, this is entity, this. I think that this time, 5 entities. Okay?
So how many tables do we need to
That's the next
represent
job.
this?
We will discuss the next class. That's a good question. That's our goal. We need to create a table later, right? Then we will see how can we address this problem. That's a very good question, because the database that we are going to use, which is a relational database, cannot handle this case, unfortunately. So we need to find a way. So we will see in the next chapter. Why don't you set aside in the next chapter? Yes.
So we only have 2 superclasses here, right?
Here.
Owner and registered vehicle.
Yes, this is a superclass. Group of superclass. Okay, that's different from this one. Okay, so typically we have the superclass and relationship as subclasses categorized. But this one is opposite way. We have a superclass, but this superclass union. Okay, union as one superclass group, then inherit to the owner. The most important thing is whether inherit. Which one is the primary one and inherit to the data. This is not this way. Okay. So this is an example of our university database. Okay. Then we can understand. Here we can find the union type, which means this is a subclass, and this is a superclass. So faculty, information, graduate, student are superclass group and inherit to the instructor, researcher. Okay? Then faculty, key of faculty is social security number because it's an inherit. Okay? And graduate student is from student or a person, so it's not. You don't have to create the surrogate key, social security number, because it's all inherit to this one. However, it will have faculty information as well as graduate student information. Okay? And the other, I think you can understand the most of the.
Here also there is only one entity, right, sir?
Let's see how many entities we have. So this is the person inherit to this one, and current section is, I think, the entity here, right? There's no inheritance. And we have a person entity, and this is inherited, and this one. Section is the entity, department is the entity, and college is the entity, course is the entity. How many? 1, 2, 3, 4, 5, 6 entities. Okay. Anything that you can understand from this EER diagram?
So I see that there is an entity called instructor researcher. That's a union of two superclasses, right?
Yes, it's a union. So this is the subclass of this one. But in this case, it's inherited from faculty as well as graduate student. Okay? So either it's a kind of category. Anything else? We learned the double. The over means it's a multi-valued. We will take care later. And also, this is a many-to-many relationship. Many-to-many relationship has the attribute also. Okay? And also, pretty much we covered the most of the information. You should be able to understand what is the university database from the ER diagram. Okay? You do not have further question? There's different ways of the notation. We can use the UML. The notation, this is an example of the UML diagram for the same, the person database in university. Okay? You can see the person class and the employee, okay, attribute. I'm going to quickly jump for this one. Have you ever seen the name of ontology? Actually, the author of this textbook, Dr. Ramesh Al-Masri, he was kind of founder of the ER modeling a long time ago. So then, he has been focused on how we can keep the information in the database. But if we still, when we keep the data in the database system, our main focus is what? Performance. If we have small data, small information, we can still use memory database. Memory data structure. We don't have to use the Oracle database. We don't have to use the file system. Just the memory structure is enough. Because we have very large data, we need to something well-organized data structure, that is relational model or something. What if the meaning of the data, meaning of information? Because we have been focusing on the performance to manage the very large data. However, people are interested in the specific information or meaning of the information. When I type the Apple, what does that mean, Apple? Company? No. It's the name of a fruit. How do I know? Database cannot recognize such a difference. Okay, when you search, when you select the data, you will learn how to select the data using the SQL. Select from the database where name is Apple. Maybe Apple company, but I'm interested in the fruit of apple. How do I know? So such a meaning, semantic meaning, is there any way to keep the meaning of the data? So ontology is one of the ways to keep such a semantic meaning of the data. If we can do, it will be sensation in the information retrieval. Like the Google cannot compete. Google tried to address that problem. But nowadays there is a clue to do the, which is called the semantic search, semantic computing, semantic whatever. Such a semantic search, there's a clue. How? What about the Facebook? If you type the Apple, but I posted or I liked a lot of the Facebook message that are related to the Apple company. Recently, Apple announced the 3D touch whatever. Then when I type the Apple, probably 99% is related to the Apple company, right? Not fruit of Apple. So then our database can return the most recent the Apple company news like that. However, Google, that's the reason Google really scared the Facebook, their search. So Facebook usually keep the personal information, your preference. Even though you set up the privacy very strictly, people can easily guess you are in the University of Bridgeport and you like the cricket game, you like this one. From the message, from your friend, from the posted message you like. But Google actually cannot collect such a personal information until the user allow. So that is the reason the Google focus on a lot the Google Plus as a social media, but cannot compete with the Facebook. Okay, that is ontology just for your additional information. We are not going to cover the ontology part here. Then finally, we are in the main part of in this course, that is a relational model. Let's go back to the very beginning of this semester. So what is this? This is the information. Information are everywhere, everything. So like the temperature information, the your feeling, the student, the status, everything. But we don't need all the information, right? So Google actually collects all information from the web. So and they have their own indexing, whatever. But in our database design, we don't need all of this. Instead, we need data. Data is some important, also related information. Okay, related means it's organized. Organized means it's a structure. That is the reason we use the ER modeling. For what? Organized and important, related information. Is it database? No, it's not yet. Even though we identify the key attribute, whatever, we don't discuss yet about the table. We don't discuss yet about the computer system. We don't discuss anything about the software or the program language, nothing. It's just conceptually. Conceptually, the organized such information that is the ER model, conceptual model, or ER model. It can be used to organize your room also. It can be used for the object-oriented program. It can be used for the company system modeling. Anything it can be used. It's a high-level modeling or conceptual modeling. But our goal is what? For example, using Oracle database or SQL Server, MySQL, using such a software, we try to create something table. Right? To do that, this one does not fit to such a Oracle database, such a MySQL database, such a database system, such a computer system yet. So we need to reduce the gap. That is called database modeling. This is called data modeling. from information to the data. It's a data model. This is database modeling that focus on the database software running on your computer. Finally, we move forward to the database system. So information is here, database over there. So we try to get close to one step by step. So this is the first step. The second step is we are going to define what is a database model. There are many different types of the database model. Hierarchical database model, network database model. So for example, hierarchical database model is we have bank. Bank has branch, New York branch, and LA branch, and headquarters. Each branch has customer account and customer account. And each account has the loan account and saving account. Loan account, saving account. Something like that. Hierarchical structure. So when you find your account, loan account, you need to go to next level, finally you can find your account list. So very fast. What you need to do is go to the next level, children, then finally you can get the data. Problem? What about the average, total average balance of the loan account in this bank? You need to up and down. If you have the 500 branches, up and down 500. It takes long time. So that is a problem of the hierarchical database model. This can be easily implemented. You can create the struct for the bank. You can create the next level. Then it can be easily implemented. And very secure, very fast sometimes. So still used in financial sector, such a hierarchical model, especially in the IBM mainframe. IBM mainframe used such a hierarchical database model. That's one of the examples. Another example is a network modeling, network database. So each data flow is defined by kind of a network flow. Object-oriented model can be used for the database. Why don't we consider data as an object? So we define one class, so person class, then instantiate for the specific person, student, instructor, and employee. So there exists object-oriented database model. Among them, in this class, we are going to use relational database model. Relational database model. So relation, we need to know what is a relation. That is the first thing. Before that, do you remember what is the basic idea of to manage very large data? So main problem is we have very large data. If we have small amount of data, we can still use memory database, memory structure in your program. Since we have very large data, we need to something different database model. Then what is the idea of to manage very large data? We borrow idea of mathematics. Set. Okay? What is the set? Group of element. Right? Element, a group of element. Just like the integer. How many integer number? How many? Infinite. There is no way to count to specify. Instead, we can define integer set. That's it. So we can do the Pythagorean theorem, we can apply to the integral, we can apply the calculus. Even though we never seen all the number, we can do whatever we want because we define the integer number as a set. Similarly, we have 1 million of employee. Do I need to define employee Lee, employee James? No. Instead, why don't we consider such a group of data as a new data structure. It's a group of data. Instead of one by one, we consider data as a group of data. So relation is what? It's a set, actually group of data. So we regard group of data, in other words, group of entities, group of what? Tuples, group of record, whatever that is, group of data as a relation. Relation means it's a set, actually. So somebody may be confused. Relational comes from relationship. Yes, that's true. So when Dr. E.F. Code, who proposed this idea, he named it as a relation because they are related. But actually relation, definition of the relation is a set of data. We consider data employed not separately as a group. So that is a relation. So first thing, when we have such a data, why don't we consider group of data as a relation? That is the relation in relational database model. Okay? So it can be defined as a group of tuples. You may see the name of tuples many times. So instead, we in the database community, we prefer to use the tuple instead of row. But practically, we use the row also. So group of tuple, that makes sense. Group of row, group of data. So it's all relation. What about this way? What are these? It's an attribute. We can also define that this is a student relation, student group. So name of the relation, name of this group, student, can be defined as name, social security number, home phone number, address, office, and GPA. That makes sense. So we can also define the relation as group of attribute. Also, it can be column later, group of columns. Okay? So relation is group of something, group of data, group of tuple, group of the attribute, group of column is a definition of relation. Just like the set is group of element. So we regard the data as a group, not individually. Okay? That's the key point. That's the main difference from the memory database. That's different from object-oriented concept. So we consider the data as a group. Okay, that is a relation. So, however, it is true, relation looks like table style. So later, this guy, vendor, company who developed the database software, like the Oracle, Informix DB2, they named this is table. Okay, it's the same name. So it's an informal name of the relation. It's called the table. Okay, so for example, student. So this is the summary of the definition. This is an informal term. Informal term means used in generally, so practically used in the company or the software. And formal definition, formal term means it's a mathematical term. When Dr. E.F. Code proposed this one, he used this term, still used in technical paper or the formal, the textbook. So, which means the relation is the same as table. Attribute in the relational model is the same as column. And let's skip this one. The tuple is the same as row. And schema, what is a schema? It's a description of your database. It's a table description, table definition. And state of the relation, state means database state means it's a current state. Current state of the database means we have the table, relation as well as the data. So state means populate the table. Populate means create the real data, instance, example, real data are created. The last one is the domain. What time is it? It's already this. So let me finalize with the definition of the domain. Domain means, so when Dr. E.F. Codd, he proposed a relational model, attribute data is from the domain. Domain means it's kind of a jar. So phone number, this is the jar, the bucket, huge bucket that includes all the phone number in United States, which means 111, 111, 1111, right? 3 digit, 4 digit, area code and the other number. All the number are in this. So when you create a tuple data, phone number, we have phone number here. So phone number, when we create the tuple of the phone number, we select data only from this chart. Okay, this is called phone number domain. What about the address? It's an address domain. It's a big bucket that includes all of this. What about the name? It's a big bucket that includes all possible name. Okay? Then, when we create the tuple, we can pick up one of the name from the name domain, one of the social security number, one of the home phone number, one of the address from the domain, each domain. That is domain. However, it's actually easy to understand practically. It's conceptually makes sense. However, in the computer system, it's not practically easy. Why? We need to keep all possible phone numbers there. Is that possible? No, practically not possible. Instead, we are going to use data type. Okay? It can be defined as 10-digit number, for example. However, 10-digit number, not always phone number, right? It can be different to just a 10-digit number. So actually, the data type cannot reflect the original meaning of the phone number, but domain, but practically it is much easier. So in the computer system, the database management system, they use the data type. But some of the DBMS still use domain. So in special cases. So that is the domain in formal term, but practically we use the possible column value, which can be formatted by data type. Okay, so we will see the terminology of the relational model next class. Then, as he asked, how can we handle the ER modeling or ER modeling to the relational database the next class. Okay.